As promised in our last podcast, let's move on to understand the basics of artificial neural networks. But before we do that, let's understand first the algorithm that gave rise to the logic of neural networks, called as Perceptron. Imagine that your system has two features. Just an example. So the input feature or the feature vector can be x1, x2. Now, in our previous example, x1 can be, say, the length of the vehicle, and x2 can be the number of gates a vehicle has. So it's just a generalization. You call any two features of your feature vector or of any sample to be x1 and x2. Now imagine that there are two neurons, neuron 1 and neuron 2. To make a picture of these clear in your mind, imagine these two neurons are two balls placed one above other, and let's name it B1 and B2. Now give your feature vector to these balls. How will you do this? Give your x1 to B1, your x2 to B2. Now your B1 has the input x1 and your B2 has the input x2. What you should do next is assigning the weights to each of these balls, say W1 to B1 and W2 to B2. Now what these weights are, these are nothing but numbers from 0 to 1. What I'm going to do next is tell you what will be the output of B1 and B2 with weights W1 and W2 when given the inputs x1 and x2. Is it becoming too much for you to imagine? I'll give you a clear picture. Imagine x1 coming towards B1 and imagine an output coming out of B1. Similarly, imagine x2 coming towards B2, and we are going to understand what will be the output out of B2. So the output of B1 is going to be the weight of B1 multiplied by the input given to it. So the output of B1 will be x1 W1. Similarly, the output of B2 will be x2 W2. What you just understood is half picture of perceptron. Now let's get into the other half. Remember, we're trying to understand how a perceptron works, and currently we are imagining a picture of perceptron in our brains. I ask you to imagine two balls, B1 and B2, right? Now could you place another ball, B3, in front of these for me, please? Well, now we have B1 above B2, and in front of these balls we have B3. Can you imagine what the input to the third ball, which is B3, be? It's nothing but the summation of x1 W1 and x2 W2. Yes, so x1 W1 plus x2 W2 is the input which goes to the output neuron, which is B3. And what does B3 do? How will it behave? What should be its output? Hear it out. B3's output will be 1 if W1 x1 plus W2 x2 is greater than a number, and it will be 0 if W1 x1 plus W2 x2 is going to be less than a number. That's all. And what this number will be, well, it depends on you or the user. It's as simple as that. That's the basic of perceptron, and that's how it works. The output neuron gives an input 0 and 1 depending on the comparison of a number with its input. And what do you think this number is? It's, in scientific terms, this is called as bias. So are you wondering why bias? Why this number is called a bias? Because it does some kind of bias. Let's take an example. Suppose if its value is too high, then W1 x1 plus W2 x2 will never be able to cross it, driving the output of perceptron. On the contrary, if the bias is too small, then W1 x1 plus W2 x2 will always be greater than that. Well, congratulations, you have just understood what a perceptron is. Remember simple things. There is an input to a perceptron, and the summation of that input, perceptron compares with a number, which in scientific language is called a bias. In the next podcast, you will get to know why we studied the working of a perceptron at all. For now, remember this. There's an input to a neuron, and it's multiplied with a number called weight. And the input of the neuron in the next layer, which in our case was B3, will be the summation of all the outputs from the previous layer's neurons. Stay tuned. Thank you.